this is a complicated title, Food, Energy, Water, Climate Nexus. And of course, we're dealing with, from a physical and kind of scientific point of view, food is energy, water is some sort of intermediate product, and energy is energy, and climate is water and energy put together. So we've got this complicated set of relationships. And if you thought the diagrams we were working on yesterday were complicated, if you tried to map out all of those, you would certainly get into serious trouble. Let me just... all of what we're talking about is basically predicting the future. And as you know, predicting the future is quite hard. So why don't we try and predict the past, which should be a lot easier. And in fact, most of the things we're talking about are past dependent. So in fact, if we know what happened in the past, we could have a pretty good idea of some of the trends in the future. My first visit to New Delhi was in 1967, and it's 45 years ago now. And nobody at that time would have predicted New Delhi what it is today. So at 45 years, the predictions that were being made were just so far off the mark. Delhi was a beautiful garden city. You could travel freely, you could go everywhere, no air pollution, just a wonderful place to be. I haven't ventured outside the hotel except for last night we went for dinner, so I haven't actually had a chance to really breathe the fresh air in Delhi, but it certainly looks like it's tasty. So one of the things is that 45 years ago we couldn't have predicted what was happening right now, but the reason I came to Delhi in 1967 was to meet with Mrs. Gandhi and Ayub Khan in Pakistan to discuss the issue of the sharing of the eastern waters. That was East Pakistan at the time, and we had done lots of model studies at Harvard. Very smart, we could do all sorts of wonderful things, and we came to help the Indians and the Pakistanis get together to resolve a relatively simple water conflict. Okay, that's 45 years ago. Has that problem been solved? There's a huge literature has developed on that since then. I don't think we're any closer to solving that problem than we were in 1967. All the characters have changed, but the basic interests of the countries have not changed. And I think this is a salient point from the point of view of what we're doing here, is that the technologies and how we can do things, model things, have improved vastly. But the social science, the soft dimensions, have not changed at all. In fact, they've got more and more difficult with more and more players. And in fact, when in '67 we were talking about two countries, then there was Pakistan and India, which had just completed earlier a big transboundary river solution, which everybody thought they could do this in the eastern region. Of course, shortly thereafter it became a different country, and there's tremendous animosity over this issue still after all those years. So what I'm going to do is do a little bit of predicting the past and predicting the future from the past. Let's see. Okay. One interesting slide which I have here is the Global Trends 230 Alternative Worlds. Now this is brought to us by the American Intelligence Council, which is composed of all of the intelligence agencies in the United States. Some of the use of the word intelligence with institutions like the CIA, of course, is an oxymoron. This was an agency that couldn't predict the collapse of the Soviet Empire even after it had happened. But anyhow, there are better minds at work in this. The NSA, which is National Security Agency, it also stands for no such agency, because it's always denying its existence. But they did a report which they looked at global trends to 2030. Now, this is not very far into the future. This is, when you're talking about futurism, it's always better to make a prediction long term in the future when you won't be around to be blamed for it. I think with 30 years, I might actually squeak in just under that deadline. I'm sure a lot of the other people here will suffer from these things. But certainly, I prefer 2050 myself, because that's very safe for me. Anyhow, they said there were four global trends that they had to worry about. These are all the intelligence agencies in the United States, and they consulted widely in the academic institutions. So it's pretty much a national consensus on what are important. And you see, three of them are political types of things. Poverty reduction is going to create class of greater educational attainment. Going to lead all sort of good things going to happen. Diffusion of power, there will not be a single hegemonist power. That comes as a surprise, I think, to lots of people in the United States who still believe that they are that power, but the intelligence agencies say not. Demographic shifts and patterns are going to be important. But the interesting thing that comes out, the number 4 is food, water, and energy nexus. So this is something, I didn't write this. This was what they had come to their own conclusions, that this is in fact the thing. And it is, they said, and I'll quote, the increasing nexus among food, water, and energy in combination with climate change will have far-reaching effects on global development over the next 15 to 20 years. So this is a very short-term projection. In a tectonic shift, demand for resources will grow substantially, owing to an increase in the global population from 7.1 billion today to 8.3 billion in 2030. This, by the way, is dated in December of 2012, this report. Demand for food and water and energy will grow by approximately 35, 40, and 50% respectively, owing to an increase in the global population and consumption patterns of the expanding middle class. Climate change will worsen the outlook for the availability of these critical resources. Climate change analysis suggests that the severity of existing weather patterns will intensify, with wet areas getting wetter and dry areas becoming more so. Much of the decline in precipitation will occur in the Middle East and North Africa, as well as West Central Asia, Southern Europe, and Southern Africa, and the US Southwest, pretty much a large part of the world. So that's the starting point of somebody else was thinking along similar lines. Let's see if I can. Okay, now thinking about predicting the past, I thought it would be interesting to look at the what I consider 5 great global transitions over the past several decades, which lead to the Nexus problem. I just wrote this during the summer, and I noticed last week Al Gore came out with his new book, and his book is entitled The Future, which is a pretty good title, but it has a subtitle which is 6 Drivers of Global Change by Al Gore, 6 Drivers of Global Change, The Future. A lot of them, only one of the 6 was dealing with the resources that we're going to talk about, which is interesting. He talked a lot about interconnectedness of nations. He talked about the internet, which he invented. That's what he claimed anyhow. So he came out with 6, I have 5. My 5 are very much directed towards the environment and the natural resources of food, energy, and water. So these are the 5 global transitions. Urban population transition. We've grown rapidly growing populations and large urban populations and large malnourished rural populations. Nutrition transition, rapid shifts in demand for food types and quantities consumed. This surprises a lot of people, the speed with which that has taken place, particularly in countries like China and India. The agricultural transition, shortage of agricultural land, low productivity in agriculture, huge losses in the food chain from farm to consumer, leading to industrial scale agricultural systems in the developed part of the world. We'll come back to these issues. Energy transition, shifting away from fossil fuels towards renewable energy sources, which is just happening right now. Climate transition, the large uncertainty leads to large uncertainty in food and water supplies, and leading to insecurity of supply and volatility of food prices, and impacts on hydro energy as an example. Countries like Brazil, which get most of their energy from hydro, or Costa Rica, are very much at risk from climate change on this area. So those are the things. Now let's go quickly through the components. This is something from 2008, I guess. The global population in 2007 actually reached 50% urban population. So the change is already taken. And when I talk about these transitions, I'm talking about things which I'm not sure that we can reverse. So that once people have seen Paris, they're not going to go back to the farms and live a dull life in the rural areas. But you can see that the there's something like, this is the urban population in Asia. Okay, so you see 2,000 things. It's about here, but it's going to go up. It's going to double, or more than double, in terms of the next 30 or so years. And that's going to make a tremendous difference in terms of resource use, as we'll see as we go along. The nutrition transition. This is a complicated diagram. It's based on some work of some French people. And it shows the composition of the diet. So this is the fats for carbohydrates and consumption of kilocalories as wealth increases. So the bottom line there is the energy in kilocalories per person per day, and that's, we're seeing this, the world is around about here somewhere, and the developed countries and the wealthier countries are moving down there. And you can see what's happening is the substitution out of carbohydrates into fats and oils and animal products, the thing. And even the French changed their consumption over about a 20-year period from about 10% of fats and oils to 20%. So even the much vaunted French diet changed very rapidly as the French became more wealthy and consumed more of these things. So we're talking about countries like China, which are already in this thing. This is 170 countries mapped on this diagram. So this is what's happening. There's a huge transition in what we want to eat, and the problem with that is it causes a large increase in demand for land and agricultural products, and particularly for water. We're dealing with beef, we're talking about 10 or 15 times more water per unit of nutrition that you get out of the products. Not saying that meat is a bad thing to eat, I'm just saying that it uses a lot more resources than others. Agricultural transition, this is a chart from the United States, and that shows that it's going from 1900 to 2002, and so the top line is the number of farms, and the bottom line is the average farm size. And we'll see what's happened in the United States, that the small farmers are basically going out of business, and large farms are taking over. This is not only in the United States now, we see this in Latin America, we see in Chile, Argentina, Brazil, we see it in the areas in Sudan where the Europeans and the other countries are buying up the huge tracts of land for large industrial farms. And even in countries like Malaysia, we're seeing a shift away from small farm agriculture to large farm agriculture. So this is what's actually happening, and it's unlikely to go back to small farm agriculture in the near future. The energy transition, of course, was well known. We started out in 1850, mostly on traditional biomass, and we've picked up on coal by this period of time, and then oil and gas came in, and these things are shifting around. Now we're at this point in time, and the question is, how much longer can we do that? Keep on doing that? And the irony of this is that in the United States we used to worry about energy security, and now we're behaving like drunken sailors with the amount of natural gas we've discovered. So the United States is pretending they're going to be just like Saudi Arabia, and they're going to take over the world liquid fuels market. I don't believe that's going to happen. We might be a little bit more sensible than that, although, societies which, and species like Homo sapiens, which is smart enough to make nuclear weapons which can destroy their own species, are smart enough to do crazy other things too. So I think that we can the answer is not in yet. We have to wait until 2030 or 2050, when preferably 2050, as far as I'm concerned. Climate transition is another biggie in this whole issue. It is something that we do know that the temperatures have been climbing rapidly, and we do know that CO2 has been increasing and other methane emissions. And so it's a very complicated issue, and I personally don't hope to understand it. I've tried and tried to read those models. I'm trained as a model builder myself, and after about 30 pages of differential equations, of which most of the parameters are not yet known, I decided that this is a young man's game, not somebody my age to ever catch up with that. But certainly something is happening, and it's happening quite rapidly. And we noticed that, for instance, in the Philippines, one of my colleagues was down in Mindanao just before the typhoon, and he had in his hands the EMI soil, the maps of the aridity in the Southeast Asian region, and he was interested in growing table grapes, and you need dry seasons for table grapes. So he looked at the map and said, we found a place in Mindanao, we'll go down there. Went to Mindanao, talked to the farmers. In the last 20 years, the climate has changed so much in Mindanao that you could never grow table grapes in the areas which were all the soil maps and the aridity maps show you could do it. So even on the short period of time, we're noticing some market changes. Plus the fact that the day after he left, they had the second or third huge typhoon in Mindanao, which had never had big typhoons previously, which is related to some of the temperature effects in the western Pacific. Okay, agriculture and climate change feedbacks are important. We typically seem to think that climate change is going to make a serious impact on agriculture, which it will do. But we also forget that agriculture makes a serious impact on climate. And this is a chart from, it's actually put together by Greenpeace, which makes it a little bit suspicious like the CIA. But actually this is a very good report, and I would recommend anyone to look at it. It's very serious. But you see this is direct methane and nitrous oxide emissions, and this is this percentage of the total greenhouse gases, and it ranges from 17 to 32% as the effect of agriculture on the production of greenhouse gases. This is not insignificant, and I think that this is well known, and it was well known in the IPC reports, but one doesn't hear much discussion of that in the agricultural communities who are very much concerned with producing more food. As quite rightly they are, but certainly if we're going to double food production using the conventional methods, we're going to double the effect of this agriculture if we go for high intensity fertilizer and chemical usage in agriculture. This is a chart which I couldn't resist. I don't know how well you see it. These are the sources of the greenhouse gases and their relative effect in CO2 terms. And you see that one of the big ones there is ruminants, cattle and sheep, things like that. And that's, of course, where the miniature growth is going to be because of the change in wealth patterns, the change in diet, the change in consumption. We're going to see a lot more of that. We already see it. In fact, last week there was a meeting in India with the Department of Agriculture. The Secretary of Agriculture was meeting with farmers who are demanding that they get more help for animal husbandry from the government. So it's very much, even in India, which when I came first, I was assumed was very much a vegetarian country, and I had a wonderful vegetarian dinner last night. But now the young people seem to be shifting to much more of a McDonald's venture. And of course, the problem with that is that, of course, the world population is broken into three parts. Isn't that something like Caesar's book, Omnia Gallia in tres partes divida est? There is the people who are malnourished, the people who are overnourished, and the people in the middle who are just about right. This is Goldilocks and the three bears, whatever way you put it, but certainly we have obesity at 1/3 of the global population, malnourishment 1/3, and just 1/3 are doing it about right. This clearly is a serious problem, and we saw it yesterday at lunchtime when I ordered the lamb, which was delicious, but the serving was for a family of 3. And I think we have to get away from that. But how we do that, I don't know. Nobody seems to know. Okay, water, food, and energy in megacities. This is an important issue because when you look at these things, and that's a complicated chart, but the diagram on the right shows where these places are located. These are mostly in Asia, South Asia is where the largest cities are going, the megacities. Megacities used to be defined as 5 million people, and then all of a sudden we decided 5 million people wasn't mega, so now the definition is 10 million. Come back in 30 years' time, maybe they'll use another definition. I hope not. But you see the winners, this is the predictions from the population division of the UN, And you see that the second, Tokyo is big, but it isn't going to grow much. Tokyo has absorbed as many towns as it possibly can, and until it's the total population of Japan. But Delhi is going to be the second, and Mumbai the third. And look at Dhaka in East Pakistan, in Bangladesh. When I first went to Dhaka, it was a city of 350,000 people. That was in my lifetime, in the early 60s. Now it's about 14 million in the same location, and I just hate to go there because it's just one huge traffic jam, and God, what a mess the thing is. And if it's going to go up beyond that, we have to worry about it. So but the issues of water and food, we did some studies actually last year for the GMS project with the Asian Development Bank, and we looked at the urban water, food and energy needs, and looked at it for those. And you can see there's water, food and energy required in a city for consumption. There's energy for water, there's water for food, energy for food, water for energy. And the irony is that the actual consumption, the traditional water intake for the city, which is what most water engineers deal with, is 1/10 of what the total demand for water is for a city. That all of the other water for energy and water for food predominates and much bigger, an order of magnitude or more than that. So if we're thinking about planning for cities, big cities, then we better thinking that. It can get more complicated. I don't want to go through that. This is a slide that I think is very interesting to me, at least, and I think should be a cautionary tale for the rest of us. This is shows the food price index, which is based on 100 somewhere along the way there. And this is how the food price index has gone. And these people in Cambridge plotted the riots on these things. Now, this doesn't prove causality, but gee, you know, how many econometric models would you have to make to say that there's something going on here? But whenever the food price spikes, that you get these terrible things happening. And what we're seeing right now is the food for the next year is going to be very much compromised. The FAO says we have globally, we've come down from 137 days of storage of food to 74 days of storage at the beginning of this year. And that is about one harvest away. So globally, if we have one bad harvest, we are all in really serious trouble. So that's the sort of some of the bad news. Some of the good news is how do we get to a safe place in this thing? And I think this is where, as I say, I'm pretty much optimistic that we're not going to destroy ourselves. And as I said, what we could do if we were not thinking about it very much. What happens if we can't reverse the transitions? And I don't think we necessarily can reverse those transitions. Well, we need to improve agricultural productivity, reduce food loss and wastage, reduce food demand, create rural employment to slow rural migration, create energy efficient food change, build climate and resilience and adaptability in the food system. We know how to do all of those things. The irony is that this is not rocket science. This is all known. We know exactly what to do about this. But how do we do it in a complicated situation? This is a chart from the Sustainable Agriculture and Climate report that came out in 2012 from the British, from Beddington. John Beddington was the chair of the meeting. If you haven't read it, take a look at it. It's an excellent report. And this is one of the charts from it, which shows the black line is food demand. This is globally. Okay, and it's going up. This is 2000 and something. That's 2000 and what is that number? I can't read. 2050. How are we going to meet that if we're going to produce this thing, given the fact we have lots of resource constraints? Well, one of the things is to reduce the food losses. And the losses of food in the system, in fact, globally, to produce a diet of 2,000 kilocalories a day, we have to produce 4,900 kilograms of food. So with huge losses in the food chain. There's the post-harvest losses, and then there's waste. And the post-harvest losses are very high in the third world countries, and the waste is very high in the first world countries. So we see the effect is about the same, however, a huge amount of food is being wasted. So if you were able to do something about reducing food wasted, you could actually start to close the gap. This, if you increase production and increase the production per unit area, since most of the farmland is already in use. You could get a big chunk from there, and then if you could change the demand for food, and that's the hardest part of this thing, how do you actually change that? Get people to move down the food chain. You could go there. It looks like a fairly straightforward way of meeting the future, and I think this is, and they're fairly optimistic in their report. They also point out there are lots of things you need to do. Let's see. This is one of the other diagrams, and this is where you get safe. And I think this is a nice concept, and I've been promoting. This is an illegal diagram, by the way. I'm showing too many dimensions for a flat sheet of paper. But that's okay. I'm from Harvard. We don't worry about things like that. But certainly we're saying we're somewhere today in somewhere which is not quite safe. We're worried. There's 1 billion people without food, without adequate nutrition. And this is where we're in 2050 based on current trends. So the question is, how can we shift these boundaries of this safe space? And we can do it by adaptation of new seeds and all the agricultural developments we know about. We can change the greenhouse gas emissions, and we can also change the food demand thing. So we can push those boundaries around. How we do that, I don't care. I think we are all smart enough to do it, but you need to think of doing them all. There is no silver bullet. There's no magic in this thing. You have to actually do it, and that I think is a take-home chart. I think the other one. This is the last chart in the slide in the presentation. That is too complicated to read, but certainly it says these are the impacts, and the transitions are on the left-hand side: urban population, nutrition, agriculture, energy, and climate, and then how they affect. These transitions affect food, water, and energy. And this is what we'd like to be in 2050. So this is a desirable set of targets or goals, which I think every one of those are doable. And so basically I come away fairly optimistic about this whole thing. But I'm still not glad that I'm glad that I'm not going to be around in 2050. Okay, thank you very much.